Welcome to the DIY Honda Garage channel. The DTC P0234 indicates a turbocharger overboost problem, which generally suggests that the turbocharger is producing excessive boost pressure. This condition is detected by the Powertrain Control Module, PCM, which interprets the input from various sensors. The PCM is responsible for regulating the turbocharger and ensuring optimal performance while preventing engine damage. Modern vehicles, like the Honda Civic 2022 Plus, use turbochargers to improve engine efficiency and performance by forcing more air into the combustion chamber. If too much boost is created, it can lead to detrimental engine conditions such as knocking, which can severely damage engine components. The turbocharger is typically located on the exhaust manifold, and it impacts the system's overall function, emphasizing the importance of diagnosing and addressing any related faults immediately. The turbocharger overboost problem directly affects several key components of the turbocharging system. The turbocharger itself is crucial for enhancing engine performance by increasing the air intake, and its proper functioning is essential for maintaining optimal boost pressure. The turbocharger wastegate control actuator, which is integrated with the turbocharger, manages how much exhaust is diverted away from the turbine, thereby regulating boost. A malfunction can lead to excessive boost, prompting the PCM to store DTC P0234. Moreover, the PCM plays a central role in managing the vehicle's performance and safety, taking inputs from sensors such as the manifold absolute pressure, MAP, sensor, and turbocharger boost sensor. These sensors are vital in monitoring the performance and ensuring the vehicle operates within the design parameters. Several factors can contribute to the turbocharger overboost problem, signaled by DTC P0234. A malfunctioning MAP sensor can misread the manifold pressure, affecting how the PCM interprets the data and subsequently leading to an incorrect boost control strategy. The turbocharger boost sensor is also critical. If it fails, it may provide erroneous readings about the turbocharger's performance, resulting in overboost. Wiring issues such as shorts or disconnects can disrupt communication between the sensors and the PCM, further complicating the diagnostic process. Lastly, a malfunction in the PCM itself could prevent it from properly controlling the turbocharger and interpreting sensor inputs correctly. Each of these causes must be thoroughly investigated during the troubleshooting process. When malfunctioning conditions associated with DTC P0234 occur, several symptoms may be observed. The most common is the illuminating of the check engine light, CEL, indicating that there is a fault within the engine management system. Drivers may also experience a noticeable power loss during acceleration, which can be attributed to inadequate air-fuel mixture ratios due to excessive boost pressure. Unusual engine noises, such as whining or hissing sounds, may indicate issues with the turbocharger or associated components. In some cases, the engine may overheat as it struggles to handle the excessive boost, resulting in reduced performance efficiency and potential long-term damage. Recognizing these symptoms early can help prevent further complications. To initiate the troubleshooting process for DTC P0234, the first step involves starting the engine. Once the engine is running, the next crucial task is to hold the engine speed at a consistent 3,000 RPM. This can be performed safely by ensuring that the vehicle is in either park or neutral, especially if equipped with a continuously variable transmission, CVT, or by putting a manual transmission in neutral. This step is vital as it simulates conditions under which the turbocharger operates at peak performance, thereby allowing for accurate readings from the sensors involved. Meanwhile, the radiator fan should come on, which serves as an indicator that the engine is under sufficient load, contributing to more reliable diagnostic results. After holding the engine at 3,000 RPM, the next step is to conduct a test drive under similar conditions. This involves driving the vehicle while maintaining the same high RPM, which allows for real-time data collection regarding the boost pressure and overall engine performance. During this test drive, it is critical to record the onboard snapshot of this DTC. This snapshot captures various data parameters, such as vehicle speed, engine coolant temperature, map sensor reading, turbocharger boost pressure, and engine speed. Collecting and reviewing this information allows technicians to better understand the circumstances under which DTC P0234 was triggered, providing foundational data for subsequent troubleshooting efforts. The third troubleshooting step involves utilizing the HDS, or Honda Diagnostics System, to perform an electric wastegate test. This effective diagnostic tool sheds light on whether the wastegate control actuator functions properly. An accurate electric wastegate actuator is crucial for regulating the turbocharger's boost pressure effectively. During this process, you also want to visually inspect the turbocharger wastegate control actuator for any signs of damage or malfunction. This combined approach, using the HDS to retrieve precise data and complementing it with a thorough visual inspection, ensures that no potential faults are overlooked. If the actuator is functioning correctly, it suggests that the underlying issue may reside within the PCM or the associated wiring, rather than the turbocharger itself. After completing the necessary repairs, the final verification involves clearing the DTC codes from the PCM. This is crucial as it resets the engine management system to its default state, allowing any further tests to accurately reflect current operating conditions. Once the DTC codes are cleared, retest the vehicle's performance to ensure that the issue has been effectively resolved. During this phase, you should monitor for any returns of the DTC and observe the vehicle's response under various driving conditions. Confirming that there are no lingering issues indicates successful repairs, ensuring that the turbocharger operates within the specified limits without generating excessive boost. This final verification step reinforces the integrity of the repair process, providing confidence that the vehicle performs optimally. To prevent issues like those associated with DTC P0234, regular preventive maintenance is crucial. This includes conducting routine checks on the essential sensors, such as the map sensor and turbocharger boost sensor, to ensure they are functioning accurately. By monitoring these components periodically, potential faults can be identified before they escalate. Additionally, routine servicing of the turbocharger is essential to ensure that it remains in optimal working condition. This includes checking for oil leaks, inspecting the wastegate actuator, and ensuring that the boost levels remain within recommended parameters. Implementing a preventive maintenance schedule not only prolongs the life of critical components, but also enhances overall vehicle performance and reliability. In conclusion, DTC P0234 signifies a turbocharger overboost problem that can greatly affect the vehicle's performance and longevity. Accurate diagnosis is dependent on understanding the roles of various components, including the turbocharger, wastegate actuator, and the PCM. Each of these components plays a vital role in maintaining optimal operation, and issues with any can precipitate error codes. Following the troubleshooting steps diligently ensures that all potential faults are identified, from improper sensor readings to malfunctioning hardware. After repairs are completed, don't forget to clear the DTC codes and retest the vehicle to guarantee that all issues have been resolved. A proactive approach through regular maintenance checks can greatly minimize the risk of encountering DTC P0234 and improve overall vehicle reliability. Please like and subscribe to the channel. See you next time.